And this is our residential virtual power plant, or some customer call it VPP solution. That means if like the picture shows, house 1, house 2, and house 3 install a storage inverter system in their own house, and then their AC output is connected together. They have the grid, they have the AC bus, so they can share new energy power through this AC bus, or we can call it through the grid. And in this system, we always have the EMS device I have introduced before. We can open our Modbus protocol to this EMS device, then the EMS device can control it. And for example, if the house 2, the load consumption is very big and the solar panel cannot support it, then the house 2 can get the power from house 1 and house 3 to support the house 2. So in this system, we can realizing the power sharing between the house. Also, for example, if in the community they have the EV charge, and the EMS can send the command to our inverter to ask the battery to discharge to support the EV charge. It is also available. So what we can do for this residential VPP, we can, all GoodWe energy storage inverter has an EMS port reserved to communicate with the third-party device by Modbus ITU or Modbus TCP or some spec protocols. And so that means we are the VPP ready inverter. And the third part is about the GoodWe introduction. And this is our vision and mission. Our vision is create a new era of smart energy. And our mission is we are determined to be the main driving force in the global energy transition, create a sustainable future for Earth, for mankind, and for the future generation. And we have installed 2 million unions totaled worldwide in the last 9 years. And we have the power generation is 26,608 gigawatt hour. And this is our GoodWe family. We have the employees more than 2,300, and our R&D staff is more than 500, and we have our overseas employees is more than 70. Also in India, we have an office, and we have more than 10 employees in India. And this is our global sales revenue. In 2020, our revenue is about 244 million US dollar. And in 2021, this amount is about 400 million US dollar. This is our global presence. We have the branches, and we have our sales and the service center in many countries. And we have 2 R&D center, both in China, in Suzhou and in Shenzhen. And the production facilities is in Suzhou and another city of China, Guangde. So you can see the most of the countries that had a good development of PV industry. We have our own office or the sales service centers in some Europe countries, in India, in Australia, and in Korea, Japan, and China, US, Brazil, these countries. And this is our marketing sharing in some countries. For example, we have we share 10% in Korea, and for example, in Netherlands, with the residential, we are share 30%, and CNN we have share 50%. In India, we are sharing. We have the 20% of the market share. I think in India we are most the commercial project of the grid tied inverter. Most project is the grid tied inverter. Okay. And this is our GoodWe product. All the GoodWe product. For example, we have our residential solution from 0.7 kilowatt to 50 kilowatt, and we have our commercial industrial solution, commercial and industrial solution from 70 to 136 kilowatt. Also, we have our utility solution from 225 to 250 kilowatt. Also, we have our PV and storage solution from 3 kilowatt to 50 kilowatt. I do not introduce this 50 kilowatt inverter in this slide because this is a new product that we do not open to the market now, so I do not introduce it. And also, we have our own lithium batteries. We have the battery we are the battery manufacturer now, not only the inverter manufacturer. So we have our own lithium battery that can work with GoodWe storage inverter and for both single phase and three phase, both the low voltage and high voltage battery. Except this inverter and battery, we also have the smart energy management system that this is free for our customer to use now. You can, if you get the GoodWe storage inverter or grid tied inverter, you can use this smart energy management system. We call it the SEM system, SEMS, the SEM system. You can use it for free now. You can check your data, your inverter data, or you can remote control your inverter to upgrade it to, or you can check the inverter data remotely. So it is very convenient to our customer to use it, and it is free for you now. And yeah, this is all that I want to share to you to introduce GoodWe, to introduce GoodWe storage inverter solution, and to introduce some marketing sharing of in 2020 and 2021. And if you have any questions, we can discuss now.
Thank you, Eric. Such a very wonderful presentation. We have a very interactive session. I mean, we expecting from the candidate to be asked more questions regarding this. The solution which we have presented was fantastic. I think that is going to solve especially the consumer, commercial and industrial segment, which people in India can look forward for, deploying the best system with their PB, existing or maybe the new deployment could be expecting from this side. So, dear participant, if you have any question, then do put up in the chat box, or you'd like to speak directly with the expert, you can just raise your hand and we can give you notice to you can speak. Any one of you have any questions so far? So, if not, then I have few questions which I would like to discuss, Eric, with you.
Yeah.
Yeah. So, Eric, I just wanted to know one thing. The AC coupled system, which you were discussing, the solution which you have, you were. I have few questions which I would like to clear from you. Okay. So the AC coupled system which you integrating with the on-grid inverter.
Yeah, the AC coupled solution is always we work with the on-grid inverter.
So can we this on-grid inverter could be a normal inverter? I mean, the normal grid feeding inverter which we normally use in the rooftop solution.
Yeah, of course.
Yeah, so replacing with your AC coupled system with the any other the manufacturer inverter, there should not be an issue. I'm asking with your AC coupled system solutions, if we wanted to integrate the other make of the inverter, the grid inverter, there will be any issue or it will be run without any problem?
Yeah, we can show because in this system, the on-grid inverter is connected to the grid directly. And also it connected to the AC coupled inverter grid output. And I think both the on-grid inverter output and the the GoodWe AC coupled inverter output both meet the requirement of the local grid. So for example, we have the certification from IEC or others. So both the on-grid inverter and the AC coupled inverter can connect to the grid. We have the certification, and then we do not to control the we do not have the method to control the on-grid inverter, because on-grid inverter only the only thing that the on-grid inverter need to do is to invert the solar the DC power of solar panel to the AC power. Then it gives the AC power to the AC coupled inverter to store it to the lithium battery. This is the only thing that on-grid inverter to do, and the AC coupled inverter do not communicate to the on-grid inverter and will not control its working. So until now, we do not meet the problems that our GoodWe AC coupled inverter with other brand on-grid inverter. We do not meet the problems now, and we think it do not have some problems.
Yeah. So the what do you mean by, like you were saying that both do not communicate the AC coupled inverter with the on-grid inverter, integrating both together. So it means that both are working in a parallel.
We do not have the communication.
Yeah, so that's what I'm saying. If there is no communication between the AC coupled inverter and the grid inverter, which on-grid inverter, which you are bringing in a hybrid system, so that what you say that both are working in a parallel.
You mean in I'm not sure because
okay, fine. That's fine. You can discuss also. There is one point which you were saying, the unbalancing output solution which you have can work in the even the unbalanced output. So that means even there is unbalanced load condition. So there will not be any fluctuation, or there's I mean the system will not trip in particular condition. If suppose say one phase has a higher load and compared to the other phase, probably is suppose variation is maybe 30% or 40% more than that, then still the inverter will working without any hiccup.
No. I will explain it. For example, if the inverter is 10 kilowatt for three phase for our ET series, and the maximum output of each phase is 3.3 kilowatt.
Right.
So the maximum load is 3.3. So if you connect the single phase load, that the load consumption is 4 kilowatts, that it only gets the power from GoodWe storage inverter 3.3 kilowatt, and the other 0.7 kilowatt is from the grid. So in this 100% unbalanced output solution, the GoodWe storage inverter do not have the overload capacity. We only have this three-phase unbalanced output capacity.
So it's kind of net metering condition wherein you have the consumption from the solar, you're taking the balance out from the grid side. So in this condition, what you're saying that the balance capacity shortfall power could be taken from the grid. That is what you mean by this unbalanced output.
Yeah.
Okay. What I was assuming that normally in a hybrid system or off-grid, complete off-grid system, when you are connecting the load and on three phases, if it is unbalanced, then normally system has issue. If it is more than 50% unbalanced, suppose RYV phase you have and you have connected the load, suppose for a 30 kilowatt system, the one phase you are connecting 5 kilowatt and the other two phases you are connecting 15 or 20 kilowatt. Then what happened normally, it trips, the system got tripped, the normal inverter, the hybrid inverter or the off-grid inverter, if it is. So that is the unbalancing of the load for connecting this off-grid system.
Yeah. If the load consumption is beyond the inverter maximum output, the other power will support it from the grid. So if there is no grid, the GoodWe storage inverter cannot support the backup load if the backup load is more than 3.3 kilowatts for a 10 kilowatt inverter. Yeah,
I got your point. So I understood. Fine. So normally what happened, many people when they connect, especially in the tier 2 or tier 3 cities in India, the load is very varied, and consumer are not that much, educated. So they do not know that what load they have to be connected. And normally the company suggests them that you should not go beyond that defined limit of the load to be connected on the system, the off-grid or hybrid system. But sometimes they connect some resistive or inductive load that create problem during the high surges current when they keep system on. Sometimes suddenly all the system getting on. So that time the inverter got tripped. So that is the problem normally happens. So that's the reason I just asked this question. So so normally the manufacturer recommend to connect the balanced load on all three phases of the system. Yeah, so thank you. I do not see any question at the moment in chat box. Still, I will request participant, if you have any question, do ask at the moment. Is we have the next session. Eric, we have the other expert from the AHA Solar who would be discussing his point, especially the DISCOM perspective in Indian context. Then we have the one panel discussion, which we all, especially the expert from the RWE, AHA Solar, you, and also I will be moderating the session. That is what we have planned for. So you would be available from the session, right?
Yeah.
Yes. So, Shatrughan, are you there? I need to give you the host right so that you can speak. 1 minute. Shatrughan, you can speak. Hello.
Hello. Yeah. Am I audible?
Yes, sir, you are audible. So let's break for 2 minutes or 3 minutes, and we can rejoin. I mean, we can start the session. Your session, sir, basically. We just give the 3 minutes break for now.
Okay.
Eric, we will be joining just after 3 minutes.
Okay.
Yeah. Samir, are you there? Yeah, he's here. Mr. Samir. Samir, now you can also be speak. You are co-host.
Yes, I'm in there.
Fine. So we all gather after 2-3 minutes break. Then followed Susan. He will be starting the session, and then we can have the.
I'm not able to share my screen.
No, it is visible to us. You have just to make it full, full slide view. The top right corner, left side. Yeah.
Yeah,
Yes.
now visible.
Fine. Yes. Yes. Fine.
So hi, good afternoon, everyone. Myself, Shatrughan Yadav. I'm CTO in AHA Solar Private Limited. So basically, I'll give you some background of AHA Solar. AHA Solar, we are AI-powered clean tech platform. We are basically doing a digital revolution kind of things in India, and we are giving digital solution to nodal agencies, government organizations who are implementing agencies in various states. Almost in 8 states, we are giving our services. Along with, we are also giving our services to EPC contractors, EPC players who are into solar photovoltaic system installations, and to the customers, wherein they can track their project progress and project reports. So this is the outline of this presentation. We will talk about some BESS, what kind of products we are using in rural area and grid in urban areas. We'll talk about some microgrid case studies. We'll also talk about the status, project status that have been commissioned in India till date, and what is the target of India, what we are doing to achieve the target. So this is the system we are all aware of it. So this type of systems are called Pico PV systems that are available and useful for rural areas where this type of systems can be utilized to do mobile charging, to play radios, and at some extent to for lighting purpose also. These are solar home system. In Eric's presentation, we had seen how it works. So these were for rural areas and in urban areas, but in utility scale solar, we will talk about first solar, then how we can integrate solar plus BESS. Basically, utility scale solar, they are large power plants, and their power which is being generated from the power plant is fed into the grid. The power fed into the grid is actually having carry a PPA, power purchase agreement, with utility or with the DISCOM. In last second quarter last year, India has almost added 1.5 gigawatt of utility scale solar. Ministry of New Renewable Energy, MNRE, is also assisting the program wherein individual for solar rooftop systems, they can get 30% to 40% subsidy of the cost. BESS in urban area utility scale. So with the growing integration of renewable into conventional energy sources, microgrids actually play a very critical role. The almost cost is around 5.5 crore for a typically 100 kilowatt and 466 kWh lithium and battery storage system. Apart from improving the reliability and cost saving of the end user, urban microgrids basically serve two purposes. They can play a vital role in reducing the diesel consumption. The first benefit out of it we are getting, and the second thing is we don't have to invest in other UPS or inverters, like we can see in rural areas of state like UP, Bihar, Jharkhand, wherein it is very we can easily spot battery plus inverter things. People are using this type of systems when there is no power outage. So this is actually we'll talk about the urban microgrid, how it works. So what is microgrid? So microgrid is basically the combination of different kind of sources from where we are getting energy. So it may be from solar, from utility, from BESS, battery energy storage system. It may be from some small wind turbine systems. If we all are integrating this type of system, then it is called a microgrid. Such a system has been installed in Delhi by BSES, uh, that is led by Reliance Industries. So in the earlier slide, we talked about the benefits of the microgrid. So here we will also talk what are the some benefits in urban microgrids. It actually increases the reliability and flexibility of the distribution networks. The same thing I will repeat here. Consumers can also avoid installation of UPS and battery systems. Uh, uh, One of the great transformative benefits of solar plus BSS in urban microgrid is to the critical loads in the establishment. So what are the critical loads? So there are possibility there are probably two kind of loads in every building. If you see, some are critical and some are non-critical. For non-critical, like ACs, so the person who can live without any equipment which is not desired or not that much critical, so that those equipments are called non-critical things. In offices or in large commercial sections wherein computers where employees are working, these are called critical loads. So these critical loads must run during the there is power outage. So these microgrids help a lot during these hours. Basically, BSS and microgrid, these things run parallel and isolated mode. We'll talk about the case study that one project we did in the CMPDI. CMPDI is Coal Mines Plant and Design Institute, that is a subsidiary of Coal India. So this was the case scenario where it has two incomers, but the power outage was very common there. Then the authority wanted to install a system which can be uninterrupted power supply. Obviously, there were DG sets also, 3 DG sets. The cumulative capacity of the DG set was 1 MVA, but we know the cost of diesel consumption is also very high nowadays. So therein we installed 200 kilowatt system. Building terrace was not that much big, but it was enough to install 200 kilowatt solar PV system. We get to install 200 kilowatt system, and the capacity for BSS was 200 kWh. These are some block diagram you can see here. There was a JCB grid, Jharkhand State Electricity Board, 2 incomer line, and total power circuit load and total panel load. These are some SLDs wherein we can spot some red diagrams where which represent actually solar integration. This is the schematic diagram. Here we can see there are 5 buildings on which rooftop system was installed, and in the center of the image we can spot BESS, which was feeding to the main building where some critical loads were available, like I said earlier, it was computers and employees were working there, and it is the power of BESS was not connected to the non-critical load. So this is kind of microgrid that that was developed. So we have seen BESS with solar plays very important role. The present status of solar projects in India, actually we are standing on 40 gigawatt in 2021. This is last 6 years progress what we have achieved in India. So the growth of renewable energy, as it was basis, but we have not achieved that much. So India has total target of around 450 gigawatt by 2030. But it is not practically actually possible due to since last 2 years we are facing the COVID situations. So a lot of project has been delayed, and a lot of projects tender has been cancelled. But we are now doing a lot of installation nowadays. In 2022 there are a lot of tenders coming, and people are doing moving very aggressively in installations. The lithium ion battery type is actually expected to dominate the market during the forecast due to its favorable chemistry and low average cost of energy storage projects. In last days, Mr. Sharma's session, he has explained a lot of things on various type the benefits of lithium ion batteries. So due to its benefit and integration with renewable projects, solar projects, they can actually create significant opportunities for the market. We obviously need a government initiative to promote the energy storage deployment in India. So basically, solar plus BESS project status in India, a lot of thing has been discussed, and a lot of thing has been pictured here. But what is the status? At what state we are now in India? So in this slide we will go through it. The total renewable energy that comprises both all renewable energy sources like solar plus wind plus biomass, it is around 92.54 megawatt. And the estimated capacity of BESS is to be around 23 gigawatt by 2030. So India has a very promising target of 23 gigawatt by 2030. We are also expecting the Indian battery storage market will rise by the CAGR of approximately 10.5% during 2022 to 27. Okay. But the main thing which will drive this market is the cost of the batteries. Since last few years, we have seen lithium ion batteries cost are reducing a lot. And at present, if you see, the battery cost is around 130. The BSS cost is around $135. So last 2 years back, it was around $200 per unit. But now it has reduced drastically. The status is like in all other reports. If you can see, the total capacity is around 20 megawatt BSS capacity, and the inverter capacity is around 20 megawatt. But in last year, later 2021, the major project was installed near Modhera Sun Temple in Gujarat, which was actually 6 megawatt solar. And the total BSS capacity, which was standard for 15 megawatt, but after negotiation, it was installed 19 megawatt hour. And one of the most attractive thing is here I have mentioned is almost 25 megawatt solar grid interactive BSS was installed in Jharkhand, rural Jharkhand area. It was under the tender where on all government buildings of Jharkhand government, there must be a solar system with BSS provision. The BSS capacity, if you see, is around 120 megawatt hour as on date, and the project is still running, and a lot of new tenders are coming in the future. GoodWe was nodal agency for this project. So this is the status in India. This is the energy generation target of India. Basically, if you see here in the table, the battery energy storage target, what we can achieve by 2030, that basically driven by the cost of the lithium ion batteries. If the cost of the lithium ion batteries by 2030 would be around $100 per kWh, then we can achieve almost 92 gigawatt hour battery energy storage. But if the cost is around 125 per unit, then the energy cost, battery energy storage solution, that we cannot deploy that much, and the total capacity would be around 58 to 59 gigawatt. So basically, this depends on the cost of the battery. Now, what next? What this was the target, and this was a very optimistic target set up by the government of India. But what initiative we are doing actually? Central Electricity Authority, they have begun the process of creating rules and enable participation of energy storage and demand response in ancillary services markets to balance the grid. So actually, BSS can also play a very important role in balancing the grid by controlling the frequencies and all. In 2021, central government has already given go ahead for inviting expression of interest for installation of 1 gigawatt hour of energy battery energy BESS as a pilot project. This initiative is also jointly managed by the MNRE, that is Ministry of New and Renewable Energy, and Ministry of Power. In recent NITI Aayog report, need for advanced chemistry, the cell energy storage is basically in India has stress on the need for cell energy storage project, because they are very optimistic with that, and they can they see that it has a very gigawatt scale manufacturing capacity can be built up in the coming years. These are, we will talk about some tenders, government tenders that has been floated in the market. In December 2021, NTPC Renewable Energy Limited, that is also called NREL, they plan to float EPC tender for 3 gigawatt worth rupees 15,000 crore renewable energy project, the solar and wind project with battery energy storage system by 2022. NREL is also set to target having 60 gigawatt renewable energy. So this is very huge target they are considering now. The RE project capacity of the NTPC is envisaged to be 45% of its total 130 gigawatt installation generation capacity by 2032. In December 2021, SECI has awarded contract to Tata for setting 100 megawatts solar project. So the project will have 40 megawatt and 120 megawatt are BESS. So 40 megawatt is the converter capacity, and 120 megawatt is the capacity of BESS. Almost it is the cost was is around 54, I think 54 crore. Sorry, $54 million. And 5% cost was considered for the operation and maintenance cost. The government of Gujarat is also government of GSECL, Gujarat State Electricity Corporation Limited. This is also the government of Gujarat undertaking company. They have tender. They actually floated tender last year and awarded to L&T. So L&T was the L1 bidder for this project, and the project capacity is 35 megawatt. And the BESS capacity that has been mentioned in the tender is around 57 megawatt hour. So that project is going to be installed in Kutch area of Gujarat. So this is the recent development. So this type of decisions will help India to get closer in achieving the target of 175 gigawatt of renewable energy. Actually, it is now revised to 450 megawatt by 2030. So this type of initiatives and government tenders will obviously drive the market in coming years. In July 2021, SECI also floated tender for procurement of power from an aggregate capacity of 2,000 megawatt hour of standalone energy systems. The project will be set on the BOOT mode. In this project, SECI shall enter into the agreement with successful bidders, like they are doing for solar projects. The same thing would be there, same kind of things and conditions would be there more or less. The government entity will into long-term agreement with the selected bidders for about 25 years. Okay, this is also believed to be the largest energy storage tender in India. And owing to these developments, the government policies are expected to be the most significant driver of the market in the near future. Department of Science and Technology are also doing some scientific developments in different kind of cell manufacturing and energy storage solutions. So this type of steps would be definitely helping India to achieve the target. The front runner is lithium-ion batteries. There are several types of batteries, but the front runner is lithium-ion batteries due to its flexible nature and its thermal stability. Also, people are looking for lithium-ion batteries. They are highly dependent. We also have seen that cost of the battery with lithium-ion is around $135 per unit. So these are some major players in this market. Toshiba Corp, Exide Industry, Delta, Amar Raja, AGS Corp. These are some major battery players. They are into the market. So thank you. Thank you, everyone. If you have any question, you can ask me.
Thank you, Shatrughan ji. It was very good presentation, and you have really put up the real perspective from the Indian context, which is very much needed to give that informative to the candidate. Request all candidates, if they have any question, they can join. We are also starting our panel discussion in which your personal queries related to the subject can be addressed. Meanwhile, anyone of you, if you have queries, please put up the question in the chat box. We will address.
Hi, Shatrughan. Thank you so much for the wonderful presentation. Samir here.
Yeah.
So, just wanted to like cross-check once again. Like, what's the dollar per kilowatt hour prices you mentioned in one of your slides?
So
and does that include enclosure or just the batteries?
So that is for BESS system. So that is almost a $135 per kWh.
So that dollar per kWh, $135.
Yes.
That includes the cell, I mean the module, the enclosure, the BOP. Does it include all?
Yes, it includes.
And that's the forecast for the future, or it's now this year?
It's now this year, but in future, if we had seen in the presentation, which was the forecast, which was presented by CEA, Central Electricity Authority, that if the prices is around $100, then we can achieve more than 92 gigawatt, and if it is 125, we can achieve 52 to 54 gigawatt hour by 2030. So the price is $135 is for as of now we can consider.
So does that corresponds to a specific supplier of batteries or inverters, or in general?
In general, it is.
Okay, because the market in Europe is completely different. When we are in the process of diversification of our battery suppliers, and what we have based on our initial RFIs is the battery prices recently got inflated based on some RMIs, raw material index prices, especially for lithium, and the battery prices are just for the module, including the enclosures, is $230 to $255 per kilowatt hour.
Yeah, so the price was, as I mentioned earlier, also before 2 years here, the prices were around $200. But nowadays it is available at the price has been reduced here.
Just to add to that, you are absolutely right. In fact, if you look at most of the publications that come from Europe, prices over around $200, current prices around roughly some more than that. But if you look at the BNEF data, which is also taken by IEFA and JMK Research of late, they talk about $137 2020 prices. So the components are not very clearly defined. Nonetheless, battery storage utility scale pricing in that report, it's given around $137, which Shatrughan has also considered.
So basically, that cost is basically for the solar this battery cells, cells and pouches, not includes the other BOP parts. Basically, if you are
Only
including the
cells.
yeah,
Okay.
only cells.
Yeah, then it makes sense to me. Yeah.
Yeah, Samir, that is the that is the case actually. Even in India, also people are getting it's almost 150, 160, 170. I have spoken few of the manufacturer or the developer who is putting up the project in the place. So that do not include the other BOP, the major BOP.
Yeah, so just for the cell, it completely makes sense. 150,
Yes,
170.
that's
And we add enclosures on the top of it, that will add up another $40 per kilowatt hour around. So that brings us to 210 or 215. And that also varies from place to place, including the transportation cost, which is quite challenging in USA, could be somewhere more because the batteries are majorly procured from Korea and China.
right.
You are right. And for Indian market, any leading manufacturer product per kilowatt hours costing would hover around something around 14,000 plus, which is essentially around, let's say, $200-ish. So yeah, that's how the prices in Indian market currently are.
Yeah. Okay. Thanks.
Yeah. So thank you, Shatrughanji. We will just starting the panel discussion in which will be a lot of questions we probably put up to the from the Samir because I just wanted to know your perspective from the as India is starting up. I mean, we can say we have not sufficient or substantial installation in the base, particularly the base system. We have only almost 20 megawatt of installation so far, and that too into the behind the meter system. What is your experience in Europe, and what is your learning? I mean, what you can keep that India has to be something they have to be adopt into the integration of the base system in India, which can accelerate the installation. The challenge which have the with the base integration with the renewable or a standalone mode. So, what do you like to say as area experience from the Europe perspective?
The challenges would be primarily, I would say, the capex. Like even despite of having advancement in terms of technologies and like the falling of the lithium-ion battery prices, despite of that, some challenges like India has very high ambient temperature. That's something which needs to be taken into account while designing the BESS, which may include a higher capex cost in terms of the HVAC installed. In addition to that, like getting them integrated in the existing wind or solar farms and getting the statutory approvals is quite kind of like a lengthy process, and this could also be a challenge. But all in all, like battery capex is still not that favorable, so that India can invest. I think so.
Don't you think there is if some subsidy or incentivizing this sector could add advantage in Indian context?
That could certainly help.
Is there the same case in Germany or in the Europe, other country? If you have any experience?
Yes, we do have subsidies on energy storage systems. Like I mentioned yesterday, when we charge our batteries from PV, not from the grid, we get around 20 cents per kilowatt hour after a certain period of time. In addition to this, there are a couple of more, like we have a kind of an index where we get credit points based on the amount of megawatt hours of battery storage system which we install. basically all IPPs. So we get that index points, and that also decides the subsidy, and it could further add up in those cents per kilowatt hour.
Right. So I think India has also started framing the policy. A lot of state has already been come up with a very good, favorable policy. They are also providing some kind of incentive or some tax benefit or some facility to set up the manufacturing unit into that state. That kind of the arrangement and support is getting discussed in India and framing this kind of the policy on the line. Uh, Thank you, Sameer. I will come back to you again. I will come to Shatrughan ji. The one question
Yeah.
which you have been working with the DISCOM very closely, especially in the Gujarat DISCOM and other the BH is also in Delhi where you have been involved into the
Actually,
discussion of.
you're not clearly audible.
Uh,
Hello.
am I? Can you hear me now? Hello,
Yeah,
Shatrughan ji?
your voice is not really audible to me.
Sameer, is it good for you? My voice?
Yeah, it is good now. Please tell.
Yeah, so Shatrughan, just what I was trying to ask you, you have been involved with the many discom with the
Mhm.
multiple discussion, and one very much discussed about the Delhi BACS is coming up with the deployment of the energy storage. They're
Mhm.
promoting it in the Delhi
Yeah.
area. So, what is the DISCOM perspective in this, whole base integration as a standalone mode and as the integration with the renewable deployment?
So basically, all discoms are looking for the integration with renewable only here, uh, not independently BS system. If we see the largest rooftop running program, Surya Gujarat here in Gujarat, that was completely for solar. But here now in new tender they have allowed BSS also for residential rooftop system. So a user or a consumer can install grid-tied rooftop systems with grid interactive BSS system. So this is from the residential consumer point of view. Apart from this, from utility point of view, if we talk about then GSCCL, which is generation company, GIPCL, they all are now uh, uh, going with the megawatt scale installations in solar plus BSS system.
Yeah, so I was surprised when I was going to the data. So far, mostly the BS, energy storage, especially the battery energy storage, best is deployed into the behind the meter system, basically.
Mhm.
What is the challenge and roadblock you see when you are deploying the front of the meter, which is, I think, that is very much needed from the utility scale perspective. Still, we do not have substantial installation from front of the meter side of the base.
Yeah, the front end meter installation that would be actually that market can be pushed by the government initiative only. The some kind of incentives probably would promote this kind of installations. If you see in past there was no any substantial development in this sector. But recently in recent last 2 years there has been substantial movement in battery energy storage system grid interactive from front end meter. But yeah, government initiatives can only push the market.
Yeah, because more often we have saw that the customers is struggling with the power quality, and also the demand side, challenges. Basically, the supply and demand challenges normally often happen with the discom. Probably they required BESS in much bigger way to install into the front of the meter, basically. So, but still substantially, we nothing has happened so far. So thank you, Eric. I would like to come to you if you are here. Eric, are you there? Eric, are you there? Eric? I think Eric is probably on mute, and let me just check he's there. Fine. So we'll come back to again on Eric. Shamir, as we have been discussing yesterday, also lot of traction, especially for the utility scale, where Europe has been the market that Europe is matured in this way to integrate best into the with the renewable large renewable. How you see India could be benefited if they are integrating best into their large renewable deployment. Almost India has so far installed solar, especially 50 gigawatt as of by 2022, January 2022. The total installed capacity in solar is 50 gigawatt, and the wind is almost 40 gigawatt. So comprising both, it is coming almost 90 gigawatt deployment of renewable. So how the base is going to change whole power scenario in the country from your experience, if you can share.
Sure. India has a huge potential in terms of renewable energy, and to unlock the key harvest from renewable energy, BESS is the only solution. So, I expect to see 30 gigawatts of at least offshore energy generation, offshore wind plants in India by end of 2030. This is based on the recent collaboration signed between RWE and Tata Power in India, which aims to deliver 30 gigawatt by 2030. And I certainly see that will open the doors for battery energy storage system as well, because like tech giants like RWE, Eon, EDF, Vattenfall, they all have expertise in energy storage, and this will certainly open the door for storage as well. Previously, we dreamt of offshore wind farms in India, but now we will be having offshore wind farm in next, say, 3 years. You will be seeing wind turbines in uh, the coast, in the offshores. So battery is also not so far. We already have some pilot projects in India with Power Grid. So I'm pretty hopeful and sure about this.
So Samir, just to add to what Prem was trying to say earlier, and in fact, the question is also for Shatrughan. The biggest, the largest pilot project for BESS in India right now, as per the information available in public domain, is essentially Tata Power Rohini substation project, which is around 10 megawatts / 10 megawatt hours, was set up with Tata Power and Fluence Mitsubishi support. Now, we are not sure about the cost dynamics of that project. Tata Power shares a lot of insights of the advantages they have had with that pilot. But a couple of other pilots are in the run, including their Leh project and a few other, I think Shatrughan also mentioned. 5 or 6 projects roughly, but all of them are essentially at the pilot stage. So is it only the cost which is a barrier to scale up such projects, what Prem was trying to say earlier, or there are other issues, including for balancing system flexibility or all these advantages are out there, but still it's not scaling up. So is cost the only barrier, or the power system needs something else behind the reduction of cost, for which trajectory has already been outlined?
Sure. Thanks for elaborating further. So the cost is one aspect. In addition to that, other barriers are possibly getting statutory approvals, which can be overcome with the current government regime. It looks like things are expediting. So then the challenge would be like getting environmental approvals, because lithium ion battery do come with a risk. Then when we have battery deployment, then how do we recycle them? So that's another challenge. India has a recycling plant already in Roorkee, but we need more of it. But we won't be sending batteries to some other countries to get them recycled. That would add up the cost, and it will reduce the salvage value further down. So these are a couple of challenges which I see for now, especially environmental point of view, we need to get the environmental statutory approvals as well. And also the regulatory norms has to be more favorable for the IPPs to bring BESS into the market, Indian market.
Right, point taken. Just to add, recently PLI scheme has also been launched, and the fund outlay has been increased in the recently announced budget as well. So it's going more than 18,000 crore plus sort of an outlay. And with the recent tender, more than 10 companies have already proposed for more than 50 gigawatt hour sort of capacity. So a lot of new things are happening. You must have also noticed Reliance made big announcement in the last couple of months or so, and so is Adani. Reliance is setting up, the whole Jamnagar area is going to be the biggest energy hub of the world. And majority of giga storage, the Tesla model is being replicated in an Indian context. And these are big, big announcements. So how do you see these are, there's so much big traction which is happening in the market for storage, particularly for storage. How is that going to transform the power sector in India? What do you think?
Definitely, India is going to be next hub. India and China, like we have the most population, and also in terms of energy consumption and generation, we're going to be the leaders. And we will be like, we have a quite ambitious goals, like adding more than or around 400 gigawatts by end of 2030. So I'm definitely foreseeing the best futures in India with this much capacity addition, because for sure 400 gigawatt additional renewable energy capacity and without battery energy storage system. So like decommissioning the existing conventional plants, adding switching over to renewables, and like that, and excess penetration of renewables would certainly bring instability, and we need to overcome that. We need energy storage systems for this. So I definitely foresee energy storage systems coming into this. And like you said, like Jamnagar is going to be the hub. We have Adani's Reliance already looking into the energy storage and unlocking the potentials in Indian market. I'm I'm pretty much sure for that.
Yeah, along with BESS, people are also looking for pump storage. If you see Odisha, where Jetcol has come up with one tender with where pump storage they are proposing with a huge capacity. So not only BESS, but yes, pump storage people are also looking where hydro facilities are available.
Yes, pump storage could also be an option. Like basically, it comes with another challenge, which is the environment and ecological point of view.
Yes.
So basically, but still we are into this innovation and exploration phase, where we could be possibly using the overhead dried up wells, or some mines which are located on a higher elevation to store this pumped water. But that's something still needs to be figured out. But in terms of battery storage, I'm quite certain. I mean, we all are quite certain.
Yeah.
Correct. Pump storage has immense value. In fact, 2 years or so, the SECI tender, it was integrated with pump storage, and the competitive bid it included, essentially it was made on pump storage. I'm not sure what is happening on that end. Nonetheless, yeah, it's an important segment, no doubt about it. So my follow-up question to both of you would be essentially, what is the scope for employment generation, particularly for the storage market today, and the way it is expected to transform the sector in the next few years? What do you think?
Yeah, there is a huge growth we can see, as Samir said, and the projection of the market is also very high. So we can see the battery manufacturing facilities would come up in India, and a lot of employment would be there. We can see in early stage of solar, there were very few installers, but nowadays or 3,000 in each state can be easily, you can find out. The same way battery manufacturers are also increasing in here in Gujarat only. We can see there are a lot of manufacturing facilities are being set up. Yes, the market is moving and traction is a lot. The lot of generation employment generation would be in the battery manufacturing facilities along with the installation of these plants.
I absolutely agree with Shatrughan. Just to add in here, I see a challenge could be potential skilled employment. So, we are expanding uh, immensely, and we need skilled employees. We need skilled workers. So, if India can launch some programs or um, to 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 train our existing manforce, our fresh engineers, uh, to skill them for renewables, energy storage, give them basic trainings, so then they are well sought in all directions, and to contribute in the renewables growth in India, including energy storage, which is a part of renewables again.
Thank you, Samir. Thank you, Prem. Thank you, Shatrughan. Prem, over to you.
Yeah, thank you, sir. So there is few questions now. I think it's good. Our discussion has been energized to the participant also. They are putting up so much questions to chat box. I think we can take up few questions. Um, One is the question they're asking. Let me read that. LFP battery offer 2,500 to 3,000 cycle, which will not serve more than 5 years in comparison to the solar plant, which has life of 25 years. Isn't this a real challenge?
Uh, no, that is not. The battery life is 20 years for now. We are still there are technology advancements which can increase or give. Basically, when we buy a battery, it's our battery. It's up to you. It's up to us how much we want to use them until the end of year 20 or 60% state of health, or we if we want we can use it even further down the line. It would be just the degradation graph of battery would not be linear. It will degrade exponentially after year 20. But again, we do have some projects where we are using batteries even after the performance warranty deadline, the time limit. So that's not a challenge. I believe I understand solar farms are signed for 25 years PPA, and batteries has 20 years lifetime. We have some augmentations in between this period which can extend the life to further 5 years, 5 more years. So an augmentation is an approach to bring the battery life to increase the battery life up to year 25, so that it is in synchronization with the PV plant. Otherwise, we can also use the batteries with a degraded capacity if the use case permits to do so, and that needs to be modeled by the commercial, several other commercial aspects needs to be taken into account there.
Yes, that is more relevant. So there is one more question has been put up by Mr. Chetan. Lithium being a rare earth metal, why the focus isn't shifting to other battery chemistry like sodium ion or graphene-based ultra capacitor or the fuel cells?
Sure. Fuel cell is already into implementation, I would say. In Germany, we have trains running with fuel cells, public commute, transport, even vehicles we do have. But this ultra capacitor is the energy density in ultra capacitor is not even close to what we have in the lithium ion battery banks. And also, ultra capacitor are only for a short term ramping rather than providing a wholesale revenue stream. Plus, graphene based battery chemistry, I'm not aware of sodium to be honest, but graphene, it seems to be quite expensive compared to lithium iron phosphate and nickel manganese cobalt. So these are the battery chemistries which permits us to which provides us an ease of flexibility in terms of various revenue streams. A battery is not intended to be provide a short-term boost. It's also used for trading. And when it comes to trading, like IPPs concerned about revenue streams, different revenue streams, because it involves a lot of capex. So like these revenue streams are very much compatible with nickel, manganese, cobalt, and lithium iron phosphate because they offer ease of flexibility. And their energy densities are significantly higher than other battery chemistries present. And in addition to this, other factors also needs to be taken into account, like safety, cost, and furthermore.
Yes. So obviously, Samir, you're right, saying that especially the fuel cells, where the application of the fuel cells is morely going to happen into the transport side, especially the the heavy vehicles transport, where the fuel cells is more a viable option. And obviously, the graphene and the supercapacitor has still to come up. The supercapacitor has a very vast potential, but still not been much commercialized in the many of the countries actually. So that is what the condition is presently. More to see in the future, this kind of deployment could be possible. Hope so.
I can see another question in the chat box. Will it give same performance after 5 years? What we will do in that case? If I understood your question correctly, after 5 years from the beginning of life, no, it will certainly not give the same performance. The battery will degrade at a certain rate depending on the use case modeling which it's designed for. And after 20 years of operation, battery will not degrade linearly. It will degrade exponentially. And what we will do in that case, we will rule out that battery, we will replace the batteries. That's the option. Current battery warranty period for lithium ion for best projects. It depends on case to case. Current performance warranty on batteries are 20 years for now, or 60% state of health, whichever is achieved on here. Starting from the day the batteries are delivered on site. Doesn't matter when you install. If batteries are delivered on site today, your performance warranty starts today. No matter if you commission your battery packs 6 months after or a year after. The performance warranty starts counted from the day it is delivered to the site, or also depends on the mutual terms with the battery supplier and the procurement team.
Yeah. Thank you, Samir, for everything. Such a nice, very well presented thought, and the exact market view which you have. Uh, I would come to the Eric. If is Eric, are you there? Eric, can you hear me? Fine, I think so. I just wanted to have this perspective also. Since they are the manufacturer, they are working on that. So, what is the strategy they are looking for to deploy such kind of large commercial investment? C&I segment is still looking for a lot of solar deployment, and integrating both with base is can be more fruitful because they're also the one of the major potential diesel consumer. Basically, PG set they depend on the critical load for PG set actually. Replacing all these PG set could from the base could be a very viable option. So just wanted to know his perspective. Anyway, we are coming to the end. I hope there is no more question from the audience so far. I would request if any one of the audience would like to speak or say a few words about this training, then please raise hand. We'll unmute them.
Maybe I see another question. I think I did not answer completely the question of Chetan Pathak.
Yes,
So,
Samir, you can go ahead. Yeah.
Time permits, maybe I can.
Yes,
So,
Samir, you can go ahead. Yes.
Thank you, Prem. So lithium being a rare earth metal, why the focus isn't shifting to other battery chemistries like sodium? Okay, so lithium is not a rare earth metal. Lithium, cobalt are not the rare earth metals. That's what the that's what recent study says, and I'm aware of. And lithium battery offer 2500 to 3D cycles, which will not serve. Lithium iron phosphate batteries even offer up to 6,000 cycles, and the plan is to augment the batteries. If they last for 5 years or 6 years, we plan to augment. Then a question: lithium ion battery disposal methods and reuse scope. This is also in relation to something which has been asked before during the discussion. Request: please shed some light on recycling and reuse of BESS in Indian context. Yeah, so we already have a battery storage lithium ion battery recycling plant in Roorkee by Ater. Ater, it's I think I don't remember the name exactly, but it's a Dutch company which has a plant, and they also plan to commission a couple of more plants in Karnataka, Andhra Pradesh, and Telangana region for recycling of lithium ion batteries. So currently, like around 80% of the batteries can be recycled. 80% out of a battery can be recycled, and we can recover 95% of the metals from the battery during the recycling, which primarily involves mechanical and hydrometallurgical recycling process. So in mechanical, we recover like plastic, lithium, and copper, aluminum electrodes. And in the hydrometallurgical, we can recover lithium, manganese, cobalt, nickel, and so on.
Yes, so thank you, Samir, for taking even some left question which you have, mentioned here. And with that, I would just request again our participants, if you anybody of you like to speak and say few words, few suggestions, or whatever you just want to speak, please do that. You are unmuted. You can right away speak with us or with our expert if you want. Arjita, you can go ahead, ma'am. You are unmuted.
Yeah. Hello. So first of all, thank you all for such a nice session for today's. And we all know that battery is a new things to us, especially for me. So it was really a nice session, and yeah, I have gained some knowledge, and I would love to attend like such more sessions in future. And I think in India we should consider some higher studies also in renewable and battery like we do in engineering is there, and so, like some like in outside India you can do master's courses. So it will be very great that if India government also think in study purpose. So in that what Mr. Samir mentioned, that skilled worker, so that will be then people can learn more if they studies, and it will be beneficial for our country also to implement all those renewable energy or battery storage system. So yeah, thank you first of all, thank you once again to all. Yeah, thank you.
Yeah. Thank you, Arjita, for such a nice and motivational word for us. And obviously, we will do conduct more such, trainings and webinars in coming future. Anyone of you again like to speak? If anyone, Suruchi, I would request you to say a few words because you have been consistently attending this session. Are you there, Suruchi?
Yes, I'm here. I'm here. So I really like the session.
especially about, I am a professional in the power sector for the past 7 years. I worked with the distribution utilities quite a bit, just entering renewable energy segment, and my interest generally lies in the new technologies. So, but yesterday's session with Samir sir was very informative. Even today's session, I learned a lot, even after so much of experience. So, thank you for that. We briefly touched upon recycling and reusing. Maybe in another session we can, discuss more on that. That is something that I see as unfolding in future for India specifically.
Yes. Thank you, Shruti.
But it was a very well organized session, and thank you for that.
Yeah, thank you so much. Welcome. Ritik Rathi, yeah, you can speak.
Hello, good afternoon, everyone. Am I audible, sir?
Yes,
Yes.
I can hear you.
Hello, good afternoon, everyone. It was really an informative session related to battery energy storage system. And I would like to join these sessions in future. Also, I request Prem sir and SCGJ to conduct these sessions in future so that we can get insights about different battery energy storage systems and other renewable energy aspects and applications.
Okay. Yes, sure, we will do that and we'll come with more such kind of training. Thank you so much. Now, Eric has been joined. I will request Eric to give his remark Eric, are you there?
Yeah.
Yes, Eric. So I was just coming to you in, I thought you were on the session. So just wanted to have your view, as a manufacturer, and as India has deploying a lot of, renewable energy in the CNI segment, commercial and industrial segment. So I just wanted to have your view on the base integration, how it could be changed and can, accelerate the deployment of renewable and could change the whole power scenario.
I think in India, most of the project now is mostly grid tied inverter system. For example, the commercial project or the utility project. So most of the solar power project only with the grid tied inverter do not have the battery, do not have the storage. But I think in the future, the storage will be more and more popular in India because the solar power is not stable. It only produces the power at the daytime, and during the daytime it is not stable. Also, during the nighttime, it do not produce any power. So, in the future, I think in India, most of the solar power project will with the battery energy storage system. And I think this is a direction of the India.
Yeah. Thank you, Eric. That is what we are also looking, and the market is also going to move in that direction, which is the BESS is the real need for if you are going more renewable integration or deployment in the country, BESS is going to be one of the very support system for viable power option in the future, and for more in context of grid quality and the grid stability, and the power quality and the grid stability.
Yeah.
That is also very much required support from the BESS integration. Thank you so much. With that word, I would request Monica to conclude the session, please. Over to you, Monica.
Thank you, Mr. Prem. Firstly, I would like to thank Skill Council for Green Jobs for this collaboration, and Eric Yang for his time, and he's from our GoodWe Solar Academy, and he has spared his time, his precious time for this session. And thank you, Eric, for taking this session.
Welcome.
And all the participants, all the students who have taken out time for this 2-day session, I hope you have found this session informative and it helps you in your future job opportunities. And we will keep organizing such more of these events and activities in the future. Keep following us, GoodWe and Skill Council for Green Jobs. Keep following our social media pages for more information. Thank you for joining. Have a very good evening. Thank you.
Yeah, thank you, Monica. And once again, there is one request from all the participants. Please, we can have since it would have the physical training, we would have the group photograph. But let's have online group photograph here. Please unmute or open your video so we can take a screenshot. I will request most of you if you can open your video. So fine. I think still a lot of people are not able to open, maybe because of certain limitation they have in the system. Once more, this fine. Thank you for the session. Yeah.
Thank you, everyone.
Thank you.
Thank you.
Thank you, everyone.